Hi, and welcome to this section of the Pre-Algebra Tutor, and in this section we're going to cover the greatest common factor. So this section will cover greatest common factor. The next section will be something kind of similar called the least common multiple. A lot of times students get these two concepts confused, but I wanted to break it up into two different sections so that you guys will have a lot of examples of each type and really understand the difference between them and so on. It's one of those things, we're building on what we've learned before. We've learned about factors before, so we've learned about that. In the next section, we'll be talking about least common multiple. We've learned about multiples, and so we'll go in that direction. Here, we're going to talk about the greatest common factor. There's something in algebra that we're going to learn a little bit later on called factoring an expression. And that basically is a way to make the expression simpler. And I don't want to get into what factoring is in terms of algebra right now, but I want to tell you that what you're going to learn in this section is going to give you those tools so that later on when we start factoring an expression, it'll be easy. So rather than lump it all together, I want to give you a lesson on greatest common factor. Then when we get on to algebraic expressions later, when we start talking about factoring an expression, it'll be easy for you because you've already got experience with greatest common factor. So this stuff that we're learning in this section is directly applicable to what we're going to learn a little bit later. All right, the greatest common factor, what does it mean? You have to look at the words, greatest common factor. So what you're going to have is two or more, in this case we're going to start with numbers, so two or more numbers, just regular old numbers. And what we're going to do is list the factors of each of those numbers. And we've already talked about how to list factors, so if you don't remember that, go back and look at that other section. But we're going to get some practice here as well. We're going to list those factors out. And don't forget, the factors of a number are really just the numbers that can divide evenly into this number. And so we're going to list them all for two or more numbers. We're going to have two lists. One is a list of factors for the first number that we have, and the other is a list of factors for the second number that we have. And what we want to do is find the greatest common one. In other words, the largest factor that is a member of both lists. In other words, we're going to list a list of factors here and a list of factors here for each number, and we're just going to look at these numbers and figure out which one is the biggest that's in both of these lists, the common factor, the greatest common factor. So it has a complicated sounding name, but really it's not a big deal. You list the factors, you look at which one is the largest that's in common to both of these numbers that you're talking about. So let's go ahead and do it. The best way to do it is by example. Let's take a very, very simple case. Let's look at the numbers 1 and 2. So if I told you, or if you were taking a test and the test said, find the greatest common factor of these two numbers. Well, this is really, really simple problem because the numbers are so small. So what you need to do is list the factors first of each number. So the factors for the number 1, let's say. The only factor of the number 1 that exists is the number 1. In other words, remember, factors, there's lots of different ways to think about it, but factors are basically what numbers can divide into this number. Well, the only number that can divide into 1 is 1, so we list that as a factor. Now, the number 2, what numbers can divide into 2? The only numbers that can go into this is the number 1 and the number 2. So, you can take 2 and you can divide by 1, you can take 2, you can divide by 2, but you can't take 2 and divide by 5, or divide by 7, or divide by 10. You can't do that. Now in the previous section, so there's no more list here. In the previous section, we talked about how to find factors. One way to do it is just to list what you can multiply together. So here we have 1 times 2 to give us 2. You also have 2 times 1, but reverse doesn't really matter, so that's why these two numbers are the factors. Here you only have 1 times 1 for this guy up here. And so number 1 is the only factor. So however it's easier for you to think, then go ahead and write down the factors. If it's easier for you to write out everything that can multiply together, to write the factors, go ahead and do that. If it's easier for you to start thinking about what can divide into this number evenly and just list all of those numbers, then do that. It's whatever's easier for you, but list the factors out. And that's what we've done here. Once we've got that done, we're just looking for, are there any factors common to both lists? Now in this case, there's only one factor common to both. So we say that the greatest common factor, GCF is what you usually see it written as, the greatest common factor of these pair of numbers, 1 and 2, is the number 1. It's the greatest common factor. It's the largest factor common to both lists. Of course, this is such a simple problem, there's only one there's only one factor in the top list, so it's not really too much thinking you have to do. But as the lists get longer and longer, you're going to be looking for the largest factor common to both of them. Okay, let's go ahead and do another one. We'll get the hang of this by doing examples. All right, what about 2, 3? Here's two different numbers. And let's go ahead and write the factors for the number 2. In other words, what can divide in to the number 2? The only numbers that can go into this is the number 1 and the number 2. So we have that list. Number 3, let's list the factors there. The only numbers that can divide into 3 is 1 and 3. And we're doing the same thing effectively that we did before. I could say that 2 can be written as 1 times 2, and that's it. Those are my factors. I can say that 3 can be written as 1 times 3. So those are my factors. I'm showing you a couple different ways to do this. Now in this case, the only factor common to both is the same one here. So the greatest common factor, again, is just the number 1. So you see, we're building upon our skills. We're building upon our skills. If you don't know how to do factors or understand what a factor is, then doing the greatest common factor is going to be difficult, and it really shouldn't be because it's not that hard. 2 and 4. Now here's when we finally get to something a little more interesting. Let's find the factors of the numbers 2 and 4. So let's look at the factors of the number 2. What can divide into 2 evenly? Well, the number 1 can divide into 2, and the number 2 can divide into 2, the same as what we found before. Now for the number 4, what are the factors? Well, the number 1 can divide into 4, the number 2 can divide into 4, number 3 cannot divide into 4, so he's not in our list, but number 4 can go into 4. So those are all of our factors. If we go higher than 4, if we try to divide 5 into here, divide 6 into here, divide 7 in here, it's not going to work. So those are all of our factors. We do have a common factor here, 1 and 1. That's true, but that's not the greatest common factor. This is another common factor, and it's larger, so that is the greatest common factor. And again, I know that this looks like a bunch of mind games and you may not see why it's very, very useful now, but later on when we're doing algebra expressions, you're going to be looking at two different terms in an expression and trying to figure out what the greatest common factor is so that you can simplify the expression. It's going to lead to a way that you're going to simplify the expressions and you're going to use it pretty much every day of your life in math. So really this is extremely important stuff, even though it seems like a silly number game. But we're building up to more complicated examples by using some simple numbers. All right. And by the way, just to make sure you understand, to find the factors of 4, I'm trying to teach you an alternate way, just see what you can divide by, like we're doing here. But if you get stuck with that, I mean, you can just say, okay, 4 is 1 times 4, 4 is 2 times 2. That's the only way you can write 4 as a multiplication of two numbers. So our factors are 1, 2, and 4. That's it. So we don't double write them. We don't care if they're reversed or not. We just write every number that can be divided into 4, which is the same thing as writing how you can multiply things together to equal 4, and go from there. All right, now let's do another one. Let's say we're going to look at 4 and 8. 4 and 8. So we're going to start a new problem here, and we want to write the factors of these guys of the number 4. What can divide into 4? Well, the number 1 can divide in, the number 2 can divide in, number 3 cannot divide in, but the number 4 can divide in. Anything bigger than that's not going to divide, so those are your factors. The number 8, we start at number 1. 1 can divide in, 2 can divide in, 3 cannot divide in, so he's not in our list. 4 can divide in, 5 cannot, 6 cannot, 7 cannot divide into it evenly, but 8 can divide into it. And so those are our factors. And so we look at our list, you say, well, here's a common factor, here's a common factor, here's a common factor to both lists of numbers, but this is the greatest common factor. So greatest common factor is equal to 4. Greatest common factor is equal to 4. So I hope that by seeing these examples, you're starting to get the hang of it. Really, the only thing we're going to do in the rest of this section is get into larger and larger numbers, so you get a little more practice with seeing larger numbers of factors. And then at the end, we'll do a couple of these things that involve variables, but it's going to be the same thing. So let's go on to a little bit bigger numbers, 3 and 9. Okay, so we want to find the factors of these numbers. All right, so the number 3, how do you find the list of factors? Well, what can divide into 3 evenly? Well, the number 1 can divide into 3. The number 2 cannot divide into 3 evenly, but the number 3 can, so he's in our list of factors. And you can't go any higher because it's not going to divide in. Number 9. Number 1's a factor. Number 3 is a factor. 6 and 5 are not factors. You can't divide 6 into 9 evenly. You can't divide 5 into 9 evenly. You can't divide 7 or 8 into 9 evenly. So really the only other thing is the number 9. So 1, 3, and 9. You do have to know how to divide and multiply pretty well to do greatest common factor. Here's a common factor, here's a common factor. This is the larger one. So the greatest common factor is 3. Greatest common factor is 3. All right, next problem. Let's say we have 5 and 9. Okay, so the factors of the number 5, what are they? Well, the number 1 can divide into 5, but 2 can't, 3 can't, 4 can't, so the only other number that you have is 5 that can divide into that. You can't go any higher than 5. Let me give you a little secret with factors. The list of factors is only going to get as large as the number itself, because as soon as you get bigger than that, you can't divide in and get anything other than some kind of decimal. So pretty much you're only going to be looking between 1 and the number that you're at to find your list of factors. All right, number 9. 1 can divide in, so he's a factor. 3 can divide in, and 9 can divide in, but nothing else is going to be able to divide in. I invite you to look at that and just see if you can find another number that will do that. So that will divide in. You won't be able to find one. So what we basically have here is the only common factor we have is this one. So the greatest common factor is 1. And you know what? This is a kind of problem. You know, a lot of students in pre-algebra and even in basic math, you know, a lot of students try to do things in their head. You know, they think that if they can do it in their head, they're really good at it or something. But especially when you get into pre-algebra and algebra and on beyond, you really can't do anything in your head. Even if you think you can, just write it down, because you're going to make a mistake eventually, and it's much more important to get the right answer than it is to do it in your head. I can't figure out the greatest common factor of some of these things, especially when we get into the bigger numbers. I can't do that stuff in my head. I mean, I have some good ideas, but I usually write everything down because it helps me visualize it. And also you have a written record of what you were thinking. So you'll be able to go back and understand what you were trying to do. All right, what about number 6 and number 9? Let's find the greatest common factor. All right, so factors of the number 6. 1 can divide into 6, 2 can divide into 6, 3 can divide into 6, but 4 cannot, 5 cannot, of course 6 can, so he's in our list. And for 9, we've done this one a lot, so we'll just write it down. 1, 3, and 9. These are the only numbers that can divide into 9, so those are the only factors. Here's a factor, and here is a factor. The one that's larger is that, so the greatest common factor is equal to 3. All right, just moving on, I'm giving you a lot of examples so that you can practice this. Let's get into some larger numbers. How about 12 and 20? How about 12 and 20? Let's write the factors of this guy. How about the factors of 12? Well, I just start at number 1. 1 can divide in, 2 can divide in, 3 can divide in, 4 can divide in, but 5 can't, but 6 can, because 6 times 2 is 12. 7 can't, 8 can't, 9 can't, 10 can't, 11 can't. The only other one we have is 12. So that's how I would usually do it. I mean, you can list out here everything that can multiply together to give you 12, and you're going to find the same list of numbers. That's fine. We did that in the other section. I'm just showing you an alternate way. All right, 20. What can we see here? 1 can be divided into here. 2 can, but 3 cannot. You can't divide 20 divided by 3, but 4 can, because 4 times 5 is 20. 5 can, because 5 times 4 is 20. 6 can't, 7 can't, 8 can't, 9 can't, but 10 can, because 10 times 2 is 20. 11 can't, 12 can't, so on, 13, 14, 15. I mean, if you keep going, you're not going to find anything else that can divide in except for the number 20, because 20 times 1 is 20. So you have a little bit nice list of numbers here. Here's a factor that's common. Here's a factor that's common. Let's see, 4 is a factor that's common. So it looks like the greatest common factor is the number 4. Greatest common factor is the number 4 for both of those things. And later on, when we start doing real algebra expressions, knowing what the greatest common factor is going to let us simplify the thing, just like you might simplify fraction, which we'll also talk about, to make the algebra expression simpler to write down. So let's go ahead and try the next one. Now, you don't need to necessarily have a list of 2 numbers to find the greatest common factor. In this case, let's find the greatest common factor of 2, 3, and 4. So we have 3 numbers. That's totally fine to do. There's no difference. All you have to do is write down the factors. And these are small numbers, so it's going to be easy. The factors of 2 are 1 and 2. Those are the only 2 numbers that can go in here. The factors of 3 are 1 and 3. These are the only 2 numbers that can divide into here. And the factors of 4 we've done a number of times. 1, 2, and 4. Those are the only 3 numbers that can divide in. So you're doing exactly the same thing. It's just that now that to find that greatest common factor, you're looking for a factor that exists in all 3 lists because it has to be common to everything. Of course, there's only one, so it's the greatest. Greatest common factor is 1. But you're doing the same thing. All right. How about 4, 6, and 8? So let's find the factors of 4. What are the factors of 4? We've done that a number of times. 1, 2, and 4. These are the only numbers that can divide into the number 4. What about 6? 1 can divide into 6, 2 can divide into 6, 3 can divide into 6, but 4 can't, 5 can't, 6 can divide into 6. So that's the factors there. And for the number 8, 1 can divide into 8, 2 can divide into 8, 3 can't, 4 can divide into 8, 5 can't, 6 can't, 7 can't, but 8 can. So those are the list of factors for the number 8. And we're looking for the greatest common. So 1 is the common factor, 2 is a common factor, but those are it, and 2 is the largest. So it's really the same process. Greatest common factor for this guy is 2. All right, now let's do one more of this triple stuff here, and then we'll get into some greatest common factor stuff involving some letters, which are just variables. All right, so let's do 12, 18, and 30. We'll find the greatest common factor of all of those guys. So let's find the factors. All right, and the factors of 12, 1 can go in, 2 can divide into there, 3 can divide into there, 4 can divide into there, but 5 can't, 6 can divide into there, 7, 8, 9, 10, 11 cannot, 12 can. So those are the factors there for 18. 1 can, 2 can, 3 can because 3 times 6 is 18, 4 cannot, 5 cannot, 6 can, 6 times 3 is 18, so you can go in that list. 7, 8, 9 can because 9 times 2 is 18. 10, 11, 12, 13, 14, 15, and so on. So the only other one left is 18 because 18 times 1 is 18. For the last one, 30, what can divide into there? 1, 2, 3 can because 3 times 10 is 30. 4 can't. 5 can because 5 times 6 is 30. 6 can because 6 times 5 is 30. 7, 8 can't. 9 can't. But 10 can because 10 times 3 is 30. 11, 12 can't. 13 can't. 14 can. But 15 actually can because 15 times 2 is 30. And if you keep counting up from there, the only other factor you're going to find is 30. So those are our list of factors for everything. 1's a common factor, 2's a common factor, 3 is a common factor, 6 is a common factor of these and this one, so 6 is a common factor. I don't see anything larger that's going to work, so 6 is the greatest common factor. 6 is the greatest common factor. So it's the same process. I think you get the idea. You could take a list of 5 numbers or 10 numbers or 20 numbers, whatever you want. You could list the factors of all of them and just look at which factors were common to all of these numbers and pick the largest one. There you would have the greatest common factor. Now, what we're going to do next, we're going to do the same thing, except these problems are going to start involving a little bit of algebra, variables. Don't forget, though, that when we do these things, anytime you see a letter, don't get worried about it. Don't worry about that it's some wacky mystical thing. When you see a letter, just try to imagine that there's a number sitting there. But you just don't know what that number is. Could be 2, could be 10, could be 95, could be anything, any integer. Okay? So let's go ahead and do that. Let's say we want to find the greatest common factor of 2 and 6x. Now when I say 6x, what I'm saying is 6 times x. X can be 3, x can be 5, x can be anything. I don't know what it is, but x is something. How do I find the greatest common factor? All right, there's a little bit of a different technique to this, because you can write the factors of 2, you can write the factors of 6, but when you have this x sitting there, it gets a little bit harder to write the factors in such a bulletproof way. All right, so really what we're going to do is this is how I'm going to teach you how to do it. We'll put 2 here, we'll put 6x here, okay? And then really what I want to do is figure out what is really common to both of these guys. What would be the greatest common factor between 2 and 6? The greatest common factor between 2 and 6. That would be 2. Okay, the greatest common factor of 2 and 6 would be 2. Now, because x is not even present in the other guy, there can be no x in your answer here because he's not even common. You know, the whole idea of greatest common factor is really finding the factors, the things that are common to both of these things. Here, you know, x is a factor of this 6x because it's multiplied like this. X is a factor of this, but there's no x here at all, so x is not a factor at all up here. So really, you're really only looking at the numbers here. You're looking at both of these things and you're trying to find out what can you pull out that would be common to both of these things. You know, when we had this list here, all we were doing we were taking these numbers and we were listing the factors out. We were looking for something common to both of them. That's really what we were doing at a fundamental level. But when you start having letters involved, then if the letter is not in both expressions, then it's not a factor of both of them. So it's not even a part of this thing. The greatest common factor of 2 and 6 is 2. If you list the factors of 2 and you list the factors of 6, then you'll convince yourself of that. We've done that a lot. So the greatest common factor is 2. Let me go ahead and just stop there for a second and go on to the next one, and I'll still be able to talk between them because the next one will be really good. If we have 2x and 6x and we want to find the greatest common factor between them. So I like to write 2x on top and 6x on the bottom. What you're really trying to do, you know, you could try to list the factors up here and you could try to list the factors down here, but the fact of the matter is that when you have the x there, it's just going to make things a little bit harder to write a list of factors. And so I prefer to try to give you the intuition to know what to look for rather than trying to write the list. What you're really trying to do, first of all, is look between the numbers and find out what the greatest common factor is there. If you do that, the factors of this guy are just going to be 1 and 2. The factors of this guy are going to be 1, 2, 3, and 6. So the greatest common factor between 2 and 6, and we've done that a million times, is just going to be 2. But in this case, x is also a factor of both of these guys. So it's common to both of them. So basically, the greatest common factor altogether of everything is going to be 2 times x. And what this is basically really saying is that when you really think about it, let's go back to a number example. When we say that the greatest common factor is 3 of these two numbers, what we're really saying is that 3 is the largest number that can divide into each of these things evenly. That's really what we're saying. Let me say that one more time. The number 3 is the largest number that can divide into both of these numbers evenly. And that's why we list them all out and pick the biggest one. But when we write 2x as the greatest common factor of these guys, what I'm saying is that 2x, whatever x is the largest number, because x really is a number overall, is the largest thing that can divide into both of these evenly. You see, if you think about it, 2x can be divided by 2x one time, because if x were just a number, it's going to be the same number in both places. So I can divide 2x by 2x, and I'm going to get the number 1. I can also take 6x and divide by 2x, and I can get the number 3. So that may be a little bit ahead of where we're at right now, but I'm just trying to get you to see that this guy can be divided by this guy. The x is common to both. 6 can be divided by 2. So the greatest common factor up here is going to be equal to 2, and the greatest common factor here is going to be equal to 2x. So my advice is, if you're trying to find the greatest common factor of two things that involve letters and numbers, then first just find the greatest common factor of the numbers and write that down. And then next, really, all you have to do is look at the letters and write down everything that's common between the two of these guys, write it down there, next to the greatest common factor that you found. That's really the most bulletproof way I can describe to do it. Let's do another one, and I think you'll see what I mean. What if we have 2x and 6x squared. And we want to find the greatest common factor of both of those. Well, I like to write them on top of each other. I don't know why. It just helps me visualize it. The greatest common factor of 2 and 6 is 2. We've figured that out already. We've done that a lot of times. So we do that with the numbers. Now with the variables, we need to find out what the commonality is between the two of these things. Now let me write one more thing down here just to make sure you're absolutely clear. When we say 2x, that's what we mean, 2 times x. When we say 6x squared, this is really 6 times x times x. 6 times x times x. That's what x squared is, right? So when we're looking at the letters, the commonality between this term and this term, really the only thing in terms of x common is this 1x. This guy is common. There's an extra x left over in the bottom guy that is not common to the top because there's another one of them down here. So if we're just looking for the simple commonality between these two guys, the greatest common factor is just going to be 2x. Same exact thing as it was before. So the greatest common factor is equal to 2x. And what this means is, and later on in algebra you'll learn how to do division when x is involved, but I can just tell you that if you take 2x and you divide by 2x, you're going to get the number 1, so that's a factor. You can take 6x squared and you can divide by 2x and it'll go evenly as well, so that's a factor. It's the greatest common factor. So just to recap, we look at the numbers, we find the greatest common factor of the numbers and we stick that down. We look at the variables and we only write down the variable that's present in both of these guys. X is present up here. We have two x's multiplied together down here, but only one of them is common to both, so we only put 1 here. The other x left over here, he's not common to both, so he's not part of the common factor. That's really the best way I can use to explain it. I'd like to do another couple of these to show you what I'm talking about. I think that when we do a few more, you'll get the hang of it. All right, let's say we want to find the greatest common factor of 6 times a times b and 10b. These are the two things that we're trying to find the greatest common factor of. So the first thing is to figure out what's the greatest common factor between 6 and 10. And you can kind of figure that off in the margin. For 6, the factors are going to be 1, 2, 3, and 6. And for 10, they're going to be 1, 2, 5, and 10. 1, 2, 5, and 10. And we've done this a million times before in the previous problem, so I'm not spending a lot of time on it. The greatest common factor is 2. So 2 is going to be the greatest common factor in terms of the numbers there. All right? Next, you're just looking at the variables and figuring out what is common to both. You have an a up here, but there is no a down here, so he's not common. You have a b up here and a b down here, so he is common. So the greatest common factor is 2b. All right? That's it. And that's probably why I like to write them on top of each other, because when you're comparing the variables, it's nice to have them on top of each other, and then you can sort of see easily what you have. All right, let's say we have 4a squared times b, and we have 20 times a times b. All right. Well, we need to find the commonality, the common factors between 4 and 20. So let's do that over here in the margin. So for 4, we're going to have 1, 2, and 4 for the common factor, for the factors of 4. We've done that a lot. 20, we'll have 1, 2, 4 and 5, and 10 and 20. And those are the common factors because each one of these numbers can divide into 20. All right? Now the greatest common factor is 4. So 4 is the greatest common factor of these numbers. Now, you just start to look at the letters. Well, you have an a squared up here and you have an a. But when you have a squared, that's like a times a. So really there's two a's up here multiplied together, but there's only one down here. So we only have one a in common with both. We have one b in common with both. So we're going to have b like that. So the answer is 4 times a times b. All right, let's say we have 7 times y cubed, and we have 28 times y. So we need to find out what the greatest common factor between these numbers are. Now, if you look at the numbers 7 and 28 and list the factors of 7 and list the factors of 28, what you're going to find is the greatest common factor is 7. So you're done with that part. Now you look at the variables. You have y cubed up here, which is like y times y times y, so you have 3 y's up there. Only 1 y down here, so we only have 1 y common to both. So the greatest common factor is 7y. The greatest common factor is 7y. All right, now what if we have 5c times d squared and 9 times c times d? Well, when we write the factors of 5 out, the only factors we have are 1 and 5. When we write the factors of 9 out, the only factors we have are 1, 3, and 9. So the greatest common factor is 1. So you write a 1 here if you want. That's fine. You don't really have to, but you can do that. Now you look at the letters. C is common to both. You have d squared and d. So there's like 2 d's up here and 1 d down here. The only thing that's common to both is just the 1d. So the greatest common factor is equal to c times d. You don't really need to keep the 1 out front because it's just 1 multiplied by that guy. Okay? Just a couple more, give you a little bit of experience. Let's say we have 12 times u times v cubed and 3 times v squared. Okay, so we write the greatest common factor, and for 12, it's 1, 2, 3, 4, 6, and 12. And I know I'm going fast, but we've done factors enough where you should be able to go through and figure out what the factors are. Those are the factors of 12. The factors of 3 are just 1 and 3. So the only thing common to both, the greatest common, is 3. So 3 is the number. Now for the letters, u is here, but there is no u down here. V cubed is up here, but there's only v squared down here. So this is like v times v times v, and this is v times v. So there's 3 v's up here, and there's 2 v's down here. So the only thing common to both is v squared, because that's 2 v's that are common to both of them. So that's the only thing that stands out. So the greatest common factor is 3v squared. Okay, just 2 more. Let's say we have 21 times m times n squared, 35 times m squared times n. Okay, and we start looking at this, and we start realizing when you take 21 and you list all of the factors, and you take 35 and you list all of the factors, then what you're going to find is the number 7 is the largest number that can divide into both of these guys evenly, because 7 times 3 is 21, 7 times 5 is 35. So that's the greatest common factor of the numbers. For the letters, you have 1 m up here, 2 m's down here, so only 1 m is common. Here you have 2 n's and 1 n, so only 1 n is common. So there you go, that's the greatest common factor. 7 times m times n. Final problem, 15 r cubed times s, 45 times r squared times s squared. Now when you look at this, when you list all the factors of 15 and you list all the factors of 45, the largest number that can divide into both of these numbers is 15. Because 15 can go into here 1 time, 15 can go into here 3 times. Now you look at the letters. You have 3 r's up here and 2 r's down here, so that's common, it's only the 2 r's. Here you have 1 s and 2 s's because you have the s squared, so s is the only thing common to both, so that's the greatest common factor. 15 r squared s. So that was a pretty good introduction, a pretty thorough, I think, introduction to greatest common factor. You should be able to do almost any kind of greatest common factor problem thrown at you. And the nice thing about it is if you can do this well and really understand it, then in a few sections when we get into factoring expressions in algebra, you're going to be looking at 2 different terms of an expression trying to figure out what the greatest common factor is. In other words, what's common to both that you can sort of pull out and divide out and make it simpler. We're going to get into that later, but this skill that you've learned here, especially when it comes in terms with the letters, okay, the variables, then that's going to make it extremely easy for you when we get a little bit down the road. So watch this section a few times if you need to. Practice these problems. All of the answers are provided. You can work them again. You can pick any 2 numbers you want and practice this, no problem. Just remember that the greatest common factor really at the end of the day, no matter how you get the answer, is the largest number, or in this case the largest algebraic expression, that can divide in evenly to both of your original things that you start with. And that's why it's important. It's going to help us simplify expressions later on down the road.